Okay, here we go. So you can see here I create an array in Python which contain a number, a string, and a boolean. So this is very convenient, right? In one array we can contain many kind of data types, but the trade-off is the speed. So each element inside this array contains its own data types. So in NumPy, every element must have the same data type. And so if I create a NumPy array like this, 1, 1, and A. So it will not allow that I have number and string in the same array, and it will try to match everything in the same data type. So it cannot transform a string into integer, so it's transform the integer into string. And I will have an array with 3 strings, like this. So you can see that. Okay. If I have an array with integer and float, then it will transform everything into float, because it cannot transform float into string, right? Okay, so the first thing to remember, in NumPy array, everything has the same data type. Okay, so we can see that we can create a NumPy array with np.array parentheses and put in a normal Python array. So okay, so I create a NumPy array. You can see one of the different, if I print A out and I print a normal array out. So one difference is you don't see the comma here, right? So that is one sign to tell you that you are using a NumPy array or Python array. But you can also print the type of A, and you can see the type of A is the class numpy.array. So it's not the, okay, I will check the type of 1, 2, 3 here, which is the Python array. And you can see the type of Python array is list. Okay. So because every element inside an array has the same data type, we can check it out by a.dtype, which stands for data type, and you will see in the array A, the data type is integer. If I have a 1.2 here, and then the first step is we will transform every integer into float, and then the data type will be float 64 for all elements inside array, inside A. So this is very important. You can check the shape. The shape is the number of rows or columns of that array. And in this case, we have one-dimension array with 3 elements. It's the shape. If I put in one square bracket here, then the shape will be, oops, what's wrong? Okay, let's take it out for a while. Then the shape will be 1, 3, which is 1 row and 3 columns, right? If I have two square bracket here, now A is a 2-dimension array, right? With 1 row. Okay. So what happens if I have 1, 2, and 3 like this? Which is the shape now? What is the shape of A now? The shape, I mean the shape of A. 3, 1. Yes. So now we have 3 rows, 1 column. Okay? Great. So the next one is the dimension, the number of dimensions. So what is the dimension of A now? 2, right? 2, because now we have like row and column inside A. So the dimension of A is now 2. So what is the dimension of the first array? 1, 2, 3. Just 1, right? Just 1.
Like, is it row?
Hmm? The dimension of the array.
It's only the row.
It's not the number of the row. It's the dimension. Like, okay, you have row and column. You have 2 dimensions. You have only one row. You have 1 dimension.
So it's only 1.
So now it's only 1 dimension. The shape is 3, comma nothing.
Shape is
The shape is
the rows and columns.
yeah, like how long is the row? How many row? How many column? So the shape is how many?
But here it's only like just 1 row, right? 1 row and 3 columns. NumPy array. The might is showing it as 3.
Yeah, because it's just 1 dimension. Then the definition of row and column is what I choose to explain. But with 1 dimension, there are no row or column, right? Just 3 numbers, right? Okay. So this is how you can access to the element. I think this is pretty familiar with you now, right? So if A has 1 dimension, 1, 2, 3, then you can access to each element by A0, A1, A2. Okay. What if we have A is 2 dimension, like this? Then now how can I access the number 1? How can I access the number 1? 1 and 1, like this? Think about it. 0, 0, exactly. 0, 0. 1. Okay. How about 3?
0, 3.
0, 3. 0, Sandy. 0, 2 or 3?
0, 2.
0, 2. Let's see. Bam, error. So think about it. Now A has 3 rows, 1 column, right? And this is the principle you need to keep in mind. Row first. Always row first. Then 2, 0, right? Okay, 2, 0 is the answer. So keep that in mind. Eh? Row first. Okay, now what if we have this form? Now how can I access 3? A 2 and 0. Bam, error. So now how many rows are there in A? How many rows has A? One row only. And inside that row there are 3 elements. So row first. Then the first row of A has the index 0. So row first. So I access to the row, which is the first row, which has the index 0. And the number 3 has the index 2. Okay? Yes. Uh, okay, the next thing is you can access to one element and change its value. So how can I change the number 2 to 5? How can I change the number 2 here to 5? A0, 1 equal 5, and then print A, let's see, 1, 3, 5, exactly. Yes, okay, the next one is we create a rank 2 array or two-dimension array which has 2 rows. So in this case, we will have B, where's B now? Here, right? Okay, so the shape of B is 2, 3. The shape of B is now 2, 3 because it has 2 rows and 3 columns. Or I can say it has 2 sub-lists inside, and each list has 3 elements. Any question? Okay, so another way you can access to the element is using, so you can use this style. That means we access to the row and then choose the element, or we can use the comma here. So with this, you can see I select the first row, comma, first element inside the row. Okay, so that means this is number 1 here. The first row, the first element. This I access to the first row, the second element, which is 2, and this is the second row, the first element, which is 4. Okay, and so with this way, I can select so what does it mean? So now I use two ranges to define how many rows I access and how many columns I access. And what is the result here?
1, 1.
So let's run it out, and we can see just 1. Just 1.
But default it takes the first row. Like if you don't mention the row.
Okay, so this is a range, right? We learned this. So this take the number 0 only, because it starts from the beginning, which is 0, and end before 1. So this means 0 only, and this also means 0 only. So, but this is different with B0 and 0 here. I will print all of them out. Okay, so you can see the difference here is, so this is a value, the number 1. And this is a sub-array from B. Right? I have B, so I can write B in this form. So you can see, so we have B, this 1, 2, 3, 4, 5, 6, and we cut off from the range 0 to 1 and 0 to 1, and we cut this number 1 out as a sub-array. So that means that sub-array of B has 1 row, 1 column, and there are only 1 element inside it, which is 1. If I change this to 2 and 2, then it will cut 1, 2, 4, 5 here. So it will cut the first 2 rows and the first 2 columns out of B, and we will have 1, 2, 4, 5 as a new NumPy array, not in value. So you get it? Okay, so I think you know it already. This is a function to generate random number. So we start with a random seed. What does it mean? Why we use the random seed?
To keep the random.
Yeah, to keep the same result in every computer when we run this. So random rand int 10 size 6 will give us 6 random number which is less than 10. Okay. And we can change the size as 3 and 4, and so oops. Okay, this is x1 with a 6 random number, and we can generate like this is a 2-dimensional array. Sorry, this one is the 2-dimensional array with a size 3, 4. So 3 rows, 4 columns. Again, we can see the row first here, right? Row first. And the next one is a 3-dimensional array. We will work on the 3-dimensional array in the exercise. So think about it. 3-dimensional array is actually just list inside list inside list. Okay, so the first list, we will have 3 sublists. In each sublist, we have 4 sublists. Okay, it's just list inside list inside list. We can see here. So this is the mother list. Inside the list, we have 3 sublists. Inside each sublist, we have 4 sublists. Okay.
So with 3-dimensional array, there is no row and column anymore. We change the concept.
The concept of row and column is just used for 2-dimensional array only, right? Because we are familiar with the table data, tabular data. So it's like with how many rows we have, how many columns we have. But it's just a 2-dimensional array. Okay, so I just print out the number of dimensions, the shape again, and we have another term is the size. The size is how many elements inside the array in totally. So if you have 3, 4, 5, which is the shape, so that means we have 60 elements. It's just the product of all shape, all size of each dimension, right?
Is there a preference over using size versus length?
It's different. Yes, good question. So what if I print length of x3 here? It should be 3 because inside x3 there are 3 elements, which is 3 lists. Right? What if I print out x3 0 here? Length of x3 0. 4, right? Because the first element of x3 is a list of 4 lists. And what if I print out x301 here? What is the length of x301? 5, right? Because inside that we have 5 elements, 5. Okay, so you can see this is a convenience way to check the size of all of the dimensions of an array, and this is a convenient way to calculate how many elements inside that in totally. Okay. So when we work with big data, so it's hard to check every element because we have like millions of elements. So so that's why print out the shape or the size it's very important to know, to debug, to know that whether your result, whether it's correct or not. So, okay. So NumPy also provide us some convenience function to create arrays. So this is a, can you guess? Oh, I write down here. Okay, this is a integer, an array with 10 zeros, 10 numbers 0. That's all. So this is in so this is a matrix with 1 row, 2 columns, all is 1. Or we can create a 2 by 2 matrix and all is 7. Here. And so this is the identity matrix. Anyone remember the identity matrix?
All are 1.
It's all 1 in the diagonal of the matrix. And the matrix is square. And in the diagonal is 1. And the other position is 0. So this is the identity matrix. So the name is I. Okay, so this is another way to generate random values. But with this, we don't have a range for the values. The values is always between 0 and 1. We can define the shape. So it will generate 2 by 2 matrix with random number between 0 and 1. Now, how can I generate random number between 1 to 10 with this function? So we know that run int gives us random number, but it's the integer number. What if I want to generate decimal number randomly from 1 to 10? Okay, this is very common. You can just multiply this with 10. Because the random number generates random value between 0 and 1. So if we multiply it by 10, it would become the random number between 0 and 10. Right? So from 0 and 1 multiplied by 10, it becomes 0 and 10. Okay, so this is the way to create a random integer number matrix with the size 3 by 3. And okay, sometimes you need to create an empty array with some element inside. So empty 3 will give us an array with 3 elements, but it won't assign anything to that. So it will check the address of 3. It will take 3 address of the space and take whatever inside that address of the storage. Okay. So the next one is we can create a set of number from 0 to 10 by np.arrange 10. So it will give us 0 to 9, or you can do 5, 8. What will I have here? It's a range again. So it will take 5, 6, 7, but not 8. Then we will have 5, 6, 7. Okay. So the last one is sometimes we want to have a number inside a range, but split equally. So it's like the x-axis. So you can use this to draw a graph later on. So with this, we take 2 and 10, and split it into 5 intervals. And then it will give us a list of 2, 4, 6, 8, 10. So notice that in this case it's inclusive 2 and 10. So it's not the normal range that we are familiar with. So from 2 and include 10, 5 interval, then we have 2, 4, 6, 8, 10.
Make it 6.
Hmm?
If we increase the interval.
If I increase, okay, if I have 6 here, yeah, then it will split 6 times. It will take like 8 divided by 6 to calculate the interval and then put the interval here.
So the number is not even with the value between 5.2 and 6.8.
Mm-hmm. Yeah. So the interval is 1.6 here. Okay. So now we move on to multi-dimensional subarrays. So we have just practiced a little bit before. So if we have A is, what is the shape of A? 3, 4, exactly. So this is first 2 rows and the first 3 columns. First 2 rows and the first 3 columns. Okay. How about 1, 2, and 2, 3?
Second row and third.
Okay. Tell me the number inside. Tell me the number.
7616.
7616.
167.
Sandy, you have only one. Sandy, tell me what is the value?
For the 1:2.
Yeah,
That
for
is
this, for this. What we have?
6.
8, 8.
No, 6 comma
5, 8.
6 comma 7.
6 comma 6, 7.
8.
Let's see. Oh, I lost connection again. Damn. Okay, so this is it will take the second row only, right? 1 to 2, it will take 1 only. And this it will take 2 only. So the second row only. And the third element only. So it's only 8, right?
But what about that 2:3?
2 to 3 is take 2 only.
That will take the third row and fourth column. For 2:3.
You mean change this to 2, 3? Or what do you want to try?
I didn't understand that. He said the 1:2 comma 2:3 means.
You want me to change this number?
Like, what does that mean? 1:2.
1 to 2 is the range, right? The range from 1 and end before 2. That means only 1.
And 2:3 means.
From 2 and before 3, just 2. So this means just 1 and just 2. So 1 and 2, which is 8.
Excuse me, the subarray is the dimension of the
Very good question. What is the shape of this? Think about it. What is the shape of this? How many rows it has? 1. How many columns it has? 1. So the shape would be 1, 1. Oh man, quarter school stuff. Okay. Reconnect. Really?
Sorry, the internet guy is fixing the internet, so he connects to virtual staff.
Okay, got it. Thanks. Where are we? Okay. So here we go. So we have only 8, but it's not the value 8. So this is a two-dimensional array with only one value 8. And the shape of it is 1, 1. Okay? Great. Okay, I will delete this comment. Okay, so again, this is interesting. So what does it mean? So the first things, this is for the row over the column. Row, right? Row first. And column 3 means?
Take 1 and 2.
0, 1.
0, 1, 2. Right? So 0, 1, 2. So that means all the rows. What does it mean?
Count
Take everything.
Take everything, but step with the interval 2. So the result should be this column, 2 steps, this column, and then this column, right? No. Okay. So we will have all of the row, but only 2 columns. Okay. Let me test you. Okay. Another thing. What does it mean?
Second row is a 5 rows.
Reversing all of the elements in the
4, 8, 7, 8.
So tell me the first column of this. 4, 8, 7, right? Because we reverse the order of the columns. 4, 8, 7. Okay. Now more interesting. What is the first column of this? 7, 8, 4, right? So it's reverse the rows and also reverse the column, but it doesn't take the first column. So then what is the last column of this?
7, 8, 2.
7, 8, 2, I think. Yeah. 7, 8, 2. Because it's in end before the second column, which is in end before this column. So that means it only take the last 2 columns. But everything is reversed. So we will have the reverse order of the column, which is now 7, 8, 4. And the last column is 7, 8, 2. You get it? Okay, again. So this means we reverse every rows. So now 1, 6, 7, 7 will be the first row. So this we reverse the column. So now this should be the first column. but we have a range for the column. We don't take every columns. We take from the last column until before 1, which means before the column with the index 1, which is the second column. So we take only last and the second last. Okay. I just want to test you to like play around with the range. It's fine. Okay, we're back to basic things. So this is the first column, people. We can select all of the rows and the number 0, which is the first column. And this is the first row. We select the number 0 and column only, which means from beginning to the end. So this is the first row. Okay. The next thing is we can reshape the array. We can reshape it. So let's see, I want to generate, I have 10 numbers or 9 numbers. I want to put it into a 3 by 3 matrix. Then what I can do is I generate a bunch of number and I reshape it to 3 by 3s. So the first step is, so what is x? What is the shape of x? What is the shape of x?
110 and 1.
It's not 110.
1, 0, 10, 1, 10.
No, it's not 110. It's not 1.
And 1.
It's not 10, 1. How many elements are there in x?
1 9.
It's not 1, 9. It's not 9, 1. It's 9, comma nothing. We have only one dimension. So 9, comma, that's all. If 9, 1 does mean 9 row and 1 columns, right? That means 2 dimension already, right? So, so 9, 1 should look like this. I will reshape x to 9, comma 1. So 9, 1 should look like this. 9 row, 1 column. So if I have a shape, I reshape x to 1, 9, then it looks like this. 1 row only with 9 columns. Okay? So if I have just a simple array, x, then the shape of x is 9, comma, nothing. Okay? You got it? Because the x now is only 1 dimension.
So what the original is show.
So this is the original shape of x.
I want to see about just this one.
Okay, just x. Okay. So x is arranged 1, 10. That means x would be 1, 2, 3 until 10, 9. Okay, so in x we have 9 number from 1 to 9, and we can play around with the reshape. So we can reshape x into 1, 9. Now we will have 1 row, 9 column. We can reshape x into 3 by 3, and we will have a matrix like this. Okay, now your questions. What if I transform x into 3, 4? So intuitively now, we don't have enough number to place 12 elements inside a 3 by 4 matrix, right? So it will give us an error. So cannot reshape array of size 9 into shape 3, 4. That makes sense, right? That's just logic. Okay, what if I place into 3, 9, 3, 2? So now I have enough element to place into a 3, 2 matrix, right? But it still gives us an error because, like, what should I do with the last 3? Right? What should I do with the rest?
5 and 2 you get
5 and 2. So is it okay? Is it okay to run this? Why? Yeah, because we have only 9 numbers from 1 to 9, and the shape 5 to needs 10 elements to fulfill. Okay, so the element of x need to be exactly the size of the shape that you want to reshape to. Okay. So this is another way to transform x into a 9 by using the keyword new axis and take all of the element. So you can just like know that exists for now. Okay, so what is the result of this comment? It will turn 1 and 2 into string because the numpy array every element needs to be the same, need to have the same data type. So in this case, it will turn 1 and 2 into float. Okay, so sometimes you can combine for loop list comprehension range of the Python to create array. Who understands this line? So for I will go through 2, 4, 6. For each I, it will create a range from I to I plus 3, which means I plus 1, I plus 2. So then the first row would be 2, 3, 4. The next row would be 4, 5, 6. And the last row would be 6, 7, 8. Magic, man. Okay, Sandy. I will go through 3, 4, 6. So for each I, it will create a range from I to I plus 3, which means 3 numbers, I plus 1, and I plus 2. Okay, so for the first time, I is 2. Then it will create a range from 2, 3, 4. And then I jump to 4, and it will create the next row, 4, 6, 5. Okay, I just want to introduce you. You don't have to master it right now. Okay, so you remember the 8.1 in the repo.it in the first round? We need to multiply a integer c with a matrix 3 by 4, right? And we need to go through each element of the array and multiply it with c. In NumPy, you can just do it like x plus 4, x plus 5, or x times 2 here. So what is x? What is the value of x? 0, 1, 2, 3. Okay, then Let's run it. Okay, x is 0, 1, 2, 3, and you can just do x plus 5, and it will automatically go through the x and element-wise plus every element of x with 5, and you will have 5, 6, 7, 8. Okay, so in the 8.1 assignment on wrapper, we have a equal 11, 12, okay, I can check this code. Okay, this is the array in the 8.1, right? So in 8.1, we need to go through A with 2 for loops, right? And multiply with C, which in this case, C is 2. But in NumPy, you can just do this. That's all. Cool, right? So it's pretty fast. And yeah, very convenient to calculate. Okay. Another cool thing is you can create a formula with x. So remember that x is an array now, it's not a variable. So it will automatically go through x, and for each element, it will multiply with 0.5 plus 1 and then square, and put a minus before it. So now you can see in this case, x is a vector. So if you remember math, basic math, so vector is a set of number, right? And with NumPy, you can represent a vector with an array with 1 dimension. And a matrix is just an array with 2 dimensions. So just keep that in mind for now. And we can do more things like exponentially with the natural number, or power 3x. That means, oops. Okay, we have 0 inside x, so that's why it cannot run the log here. So we need to change x is from 1 to 5. Okay, so you can see power 3x. That means it will take every element of x and calculate 3 in the power of x e. So we have 3, 9, 20, 27, and 18 on. Okay, NP log x is the logarithm of the number e. It's not the logarithm 10, right? If you want to calculate the logarithm 10, you need log 10. Okay, but most of the time we will use the log here, which is ln in math. Okay, so keep that in mind. Okay, aggregations. There are a ton of functions to calculate the aggregation in NumPy. So we can looking for the mean, max, the mean, or sum of them all, or this is the index of the minimum element, and this is the index of the maximum element. And we also can have the median, and so np.any, like evaluate whether any element are true. So any element inside that array are true, it will return true. If all of the element is false, then it's return false.
So the median is the dictated.
The median.
We have one.
So yeah, so median and mean is different.
Oh.
We will talk about it in the next week. Basic statistic. Okay, and so NumPy is pretty fast. You see that here I create a big array which is 1 million elements randomly from 0 to 1, between 0 to 1. And I can sum them with the built-in NumPy function sum. And I can also use the NumPy sum function. And so time IT is a method to measure the time, like we use a TikTok example. And you can see here with the NumPy, we do 1,000 loops in like the time, average time for each loop. So loop is 1 time, is calculate the code. It run the code. So this in nanosecond and this in milliseconds. It's like about 100 times faster than the built-in Python function. Okay, another thing is very cool too. So remember we have an exercise in the Python, basic Python, where we want to compare each element of an array with a value, right? In NumPy, you can just do it like x smaller than 3. And it will give you the result is true to true because x is 0 to 4, right? Let's print it x out. So x is 0 to 4 and x smaller than 3 give us true, 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 false, false. So it will compare every element inside x with 3. With this operation, it will run this, apply this operation for any element inside x and give us the result in a new array here. What is the result of x greater than 3?
All false last true.
Yes, false, false, true, true. What is x equal 3? We will have a true in the middle. What is the, oops, sorry, it's not in the middle. Okay, so last question, what is x greater or equal 3? Greater or equal 3?
Last
False, 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 true, true, right? False, 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 true, true. Yes, good job. Okay, what is x greater than 3 and less than 5? Only one true as the index of 4, right? In the last index. Okay, so you can see here I don't use the word n, right? If I use the word n here, it will fail. Because, so n is actually, we combine the object. But remember that x is an array. X has many elements inside it. The x greater than 3 gives us an array of true and false. It's not one value true or false, right? So the n is the combination between the Boolean object. But x greater than 3 return an array of Boolean objects, not a simple Boolean object, right? You get it? So that's why in NumPy we need to use the sign n here, and for or we need to use this sign. Okay, this is for n, and this for or. So it's because, like I said, the n and the or is the combination between Boolean value, Boolean object. But now in this case, we have an array of Boolean objects, not, so we want to compare the, I mean, we want to apply the content of the array, not the object, the array. Okay, so now we have an exercise for you. First step is, again, save a copy in your drive. And so remember to add this Coder School, this folder, to your drive. So if you see this is shared with me, then you need to add this to your drive. Add the photo to your drive. I think I already did it, but if you see here it's shared with me, then it won't work. Add to your drive, because the first step is we connect Colab with your Google Drive, and then we get an image from the Google Drive, from our Google Drive, and here is the image. Okay, just run through this code. When you run this, the first thing is, okay, you need to click on the link to authenticate Colab to connect to your Google Drive, and then run this code to import the image. And this is a function to show the image on the screen. And whenever we want to show the image, we call the function show image photos. Okay, so basically photos or image is just a set of number. For every pixel, we have three numbers represent for the color, RGB. So that means when you run photo.shape, you will have 3 numbers. So this is the row, which means the height of the image, right? This is the height of the image. And this is the width. So we can guess, like, okay, this number is bigger, so this must be the width, right? This is the width. Contained 760 pixels. Okay, and in the height we have 430 pixels. And for each pixel, we have 3 numbers represent for the color R, GB, red, green, blue. Okay, so now the whole image is actually just 3-dimension arrays, right? Okay, now your exercise is look into the result here and try to implement it in 1 line of code. So this is, you need to call the show image function, and then you will manipulate the object photo so that the result will be the same with this. So you might need to like keep this output, because if I run this now, this output will be replaced, right? So create a new cell here to test first. Okay, your assignment is create exactly result like this by manipulating your image, which is just an array, 3-dimension arrays. So we flip it around and we create a minor image. We pick we select slicing it, and we reduce the quality by remove 3 out of 4 pixels. And the last one is we flip it. We rotate it 90 degrees. So the hint is using the slicing, playing with the range, with the grammar colon, comma something. Okay, have fun, guys.